Welcome to Toll 101, Introduction to Tolling, Toll Principles and Practices. This program is made possible through funding provided by Aegis Projects, Inc., and with the additional cooperation of Atkins, Valencia College in Orlando, Florida, and Patterson-Bach Communications. Hello, I'm Marty Stone, Chief Operating Officer of Aegis Projects USA, a division of Aegis Group, and I'm joined today by Tom Nucky, National Toll Technology Director from Atkins, a member of the SNC Lavalin Group. Toll 101 was designed to educate a variety of audiences to the unique characteristics and value of tolling as part of the approach to finance, build, and operate viable transportation solutions in North America.
Today, most funding for highway maintenance and expansion comes from state and federal gas taxes. These funds have run low and are expected to continue to diminish, primarily because cars have become more fuel efficient. Though some states have increased their gas taxes, the federal tax on gasoline hasn't changed since 1993. Federal taxes go into a fund dedicated to transportation called the Highway Trust Fund. Since 2008, this fund has gone into the red. It's up to Congress to figure out what to do about the federal trust fund. But states have similar trust funds with the same problems. We believe tolling is a very important part of the overall solution of the surface transportation problems facing virtually every urban area in North America.
Toll 101 is divided into 7 segments that are introductory in nature. They're not designed for experts or to make you an expert. They should be perfect for those interested in a high-level view of the toll industry, how tolling works, the different approaches to toll technology and operations, things that would give someone a good basic understanding of the toll business.
This series will be ideal for engineering and planning students or new hires for toll and transportation agencies, or for the companies that support these types of public agencies. This education would also be beneficial for elected and appointed public officials who are involved in transportation.
So you can watch this series sequentially, or you can watch each section individually, depending upon your interests. Again, thank you to Tom Nucky from Atkins for helping me present Toll 101. And I hope you find this material helpful in better understanding tolling and transportation in North America. Hello, and welcome to Toll 101, Section 7, The Future of Tolling and Road Use Charging. Today we're going to be looking at the key challenges and some of the opportunities facing the toll industry today and into the future. We're going to look at the growth of tolling, how road user charging is something that the toll industry might be getting involved with. We're going to be talking about some new technologies and the new collaborative economy with things like Uber and Lyft. And we're going to talk about the impacts of these changes and how they have disrupted the toll industry. And then we're going to look at the effects on tolling today and into the future. When you look at the key challenges and opportunities, you can see that they go back to the original premise for this program. And that is, today we have insufficient funds in transportation to deal with the highway problems that we have. Most states spend their entire allotment of gas tax just on maintaining the existing highway system. There's no extra money for building new transportation projects, new roadways. In fact, most states today use tolling to build any of their new highways. Florida is a perfect example. There has not been a new highway built in Florida in the last 25 years that has not been built by a toll agency. The money is just not there. Annually, the federal gas tax generates about $30 billion. And at the same time, the annual generation of toll revenue is about $15 billion. Now, what makes that remarkable is that tolling represents less than 5% of the limited access highways in the United States. So with less than 5% of the highways, we're generating half the amount of money generated by the federal gas tax coming out of the toll business. So we think tolling is really a significant part of the solution for all of these transportation problems. There's new capacity tolling of the interstate highway system coming. There are managed lanes and new developments in express lanes that are coming. We're moving towards more tolling in a lot of different areas, converting existing non-toll roads to tolling. It's not very popular when that happens, but it's almost necessary to bring the revenue in that we need, not just to maintain, but to enhance and expand the existing system. The new collaborative economy, we're going to be talking about some of that, the changes in vehicle usage and ownership, and how that not just affects transportation, but how it affects the toll business. And interoperability, we've talked about interoperability. In fact, we had a whole segment on it, but how the interoperability and new toll technologies based on things like cell phones and GPS are really going to change the future of the toll business. And then this idea of future national transportation accounts, the entering of the toll business by third parties who really aren't transportation organizations. They are more payment and financial organizations. They're really going to affect the toll business, and they're going to be part of the mobility solution. And that term at the bottom of the slide, mobility as a service, is really a new approach to mobility that we're seeing not only here in the US, but in Europe. But all of this really begins with the growth in tolling and how that growth is really going to occur in the future.
Well, Marty, let's take a look at that growth and take a look at some projections by CDM Smith recently on the growth of tolling. So tolling is growing, but tolling still represents a small basis of the national economy, obviously. And these next few graphics are going to talk about our number of customers in millions of transponders, and that kind of equates to how many customers we have, because a transponder is a method of payment in the vehicle. So we're going to talk about the different types of tolling and how they're projected to grow over the future. So first of all, our existing toll facilities. This graph in green shows the existing toll facilities and how many transponders we expect to see, or how many customers, individual customers, we expect to see over the next few years. And you can see now we're around almost 50 million transponders out there, between 40 and 50 million transponders in circulation around the country right now. And that's going to change as we add new traditional toll facilities. As we add new toll roads, new roads to the network, expansions of existing roads, we're going to see new toll facilities generate more and more transponders, more and more customers. And then we're going to add on really the fastest growing segment of tolling, which is the managed and express lane corridors. We're adding those in now, and you can see over time those are going to have an appreciable growth in our number of customers till we project up to 2025, where we're going to have up to 80 million customers with transponders. And now we look at the potential for interstate tolls and the new capacity that brings to the interstates by adding tolls onto the interstates. And we see a huge potential increase of tolling transponder-based customers, upwards, over 140 million, as we develop more and more applications such as road user charging, congestion corridors, new transit and transit links with tolling. So we really think there's a huge potential increase in tolling over the next 10 years or so. And part of this is going to be based in these new pilot projects for new ways to collect a user fee. And these are known as road user charges, or RUCs. So this graphic shows some states that have experimented with the concept of a road user charge. And basically the road user charge is intended to replace the gas tax. The gas tax is a tax, everybody pays for it. You pay the same amount based on per gallon as the guy who drives 1 mile or the guy who drives 1,000 miles. But the road user charge flips that, takes some ideas from the toll industry where a user pays more depending on the number of miles they travel. So a road user charge fundamentally is you pay for the number of miles you travel in your vehicle. And that can be varied by time of day or by the types and locations you're traveling in. But it's a more equitable way to determine who owes what to finance the road costs.
This really is to kind of modify some of the impacts on the gas tax that we've seen over the past decade or so. with cars increasing their miles per gallon. The higher efficiency of the vehicles equals less gasoline being purchased per mile driven. On top of that, add in hybrids and electric cars. Pure electric car isn't paying any gas tax at all. So if you're relying on the gas tax to maintain the roadway system, electric vehicles and hybrids are really not paying their fair share compared to those who are running gasoline-powered vehicles. When you add all of this together with the fact that the federal gas tax has not been increased since 1993, that 25 year plus going in terms of inflation, in terms of not just the rising costs, but the real lower revenue, has placed transportation into a serious problem. So RUC is one way, road user charging is one way to address that. We think there's a symbiotic relationship between road user charging and tolling, because the likelihood is that they're going to end up using some of the same types of equipment. One of those is related to cordon tolling. We talked about this in one of our earlier segments, this idea of being able to draw a line around an urban area and charging people for driving into that central business district or that downtown urban area is one way to control congestion. But it's also a way to generate some significant revenue. And projects like London and now the new project in Manhattan are not only designed to modify congestion, they also want to generate revenue and move that revenue over towards the public transit side. And this is a concept that actually was developed over 30 years ago in Singapore, who developed the first concept of putting a ring around their CBD and charging through their ERP, electronic road pricing program, to be able to drive into downtown Singapore. And they did this using a transponder, very innovative approach, but because their land transport authority in Singapore is one agency that controls all of the highways, all of the bus system, and all of the light rail, they're able to then create one revenue stream and move that revenue over to support public transportation. They do a really good job of it there. Most cities in the US, and certainly most of them even in Europe, the highways and the transit, both the light rail and the bus systems, are often managed by different organizations, and they don't share in the same revenue stream, so they don't have the opportunity to do that. Manhattan, the new project in Manhattan, looks like it, in fact, will be doing that through the MTA, the Metropolitan Transportation Authority in Manhattan. They're going to essentially place a toll on all of the highways, bridges, and tunnels that come in to New York City. I think it's below 60th Street, right, Tom?
Below Central Park, yes, that's right.
And many of us, and I certainly was one of them, thought, oh, you already pay a toll to get into New York through the tunnels. And it was really interesting to me to find out that only 22% of the traffic coming into New York City from either the east, the north, or the west are paying a toll, and that 78% of the traffic that's coming in is coming in non-tolled. Therefore, it looks like they have the opportunity to do that. I know you guys are working on that project, so you have some
We
background.
are working on it. It's a land-breaking project in the U.S., groundbreaking from the standpoint that it'll be the first corridor congestion project in the U.S. Previous efforts were attempted in San Francisco, but Manhattan will be the first one. And really, the money here is going to be pledged to upgrade the aging subway system. The subway system has some components still running that are 100 years old in the subway system too. So to upgrade the subway system to a more modern subway, to increase the coverage of the subway and corresponding transit system, this Cordon pricing project is estimated to generate $1 billion a year that can then be bonded into a $15 billion project to really revitalize the subways and the transit within the corridor of Manhattan there, but also to provide less congestion, a better place for walkers and pedestrians and cyclists to be able to get through Manhattan.
I think this is part of that future of tolling, but the future of transportation, this idea of mobility as opposed to highways, bridges, tunnels, buses, this idea that providing mobility to users, no matter what the mode is really catching on, and it looks like New York City is embracing it. There are some pretty unique technologies being employed around the world, some of them in Europe, and certainly they might have some application here in the US in the future.
That's right. In Germany, there's an experiment, and it's an operational experiment for many years now, with the use of satellite tolling for truck users. Truck users would pass through Germany from other countries around Germany and wouldn't pay their fair share of gas tax. And so the Germans implemented what they call the satellite toll collect project, in which the toll is levied from a truck, which has an onboard unit, which is specifically designed to receive the satellite signals. Then the position of the truck throughout its travel through Germany is gathered, and that data is sent on through a mobile device inside the truck that links back to the cell network to a back office that we've talked about before, where the charges are then settled up on the account. I think it's a new technology that may find applications in other ways when it reaches the US, and it relies on satellites and cell phones.
It reminds me very much of the technology that we already have in our cars. We have GPS mapping in our cars. The satellite is only used to position where the car is. These onboard units that they're using in this GPS-based tolling system look very similar to me to be like the GPS and the Google Maps that we're using. And I know there's some fear about Big Brother when people think about satellites and them being tracked. But in this particular case, the satellite is just used for positioning to show where on the vehicle's map, where you started from, where you ended, what the mileage was, and they compute the toll based on that, correct?
That's right.
There's also some really interesting things happening on the multimodal side in technology, specifically with tolling in transit.
That's right. And if you think about the average customer is going to have a mobile phone or some device in their pocket that they use to communicate with, and being able to leverage that device to pay for your transit toll as well as your roadway or bridge toll has enormous upscale potential to it. And we're seeing now maybe the convergence of the phone to be the device that allows you to be your electronic wallet, whether it's for a purchase at a retailer, but now in the future to purchase your tolls, to purchase your gas, to pay for your to pay for your transit fares, and to bundle those all into your mobile device. And maybe as we talk later about some of the vehicle technologies, the phone may also be a gateway to that electronic purse to your vehicle as well.
I think the key element in this technology is the fact that we're using a single account. And in fact, you might end up using multiple technologies. You might have a fob and a phone and a transponder in the car, but it's all tied back to one account that allows you to maybe buy hamburgers, buy gasoline, take the bus or the light rail system, and pay the toll all out of one account. Another thing that everybody is familiar with because they've heard it a lot on television are connected and automated vehicles. And I'm using the term automated here instead of autonomous because automated is the term that the Society for American Engineering uses to describe driverless and self-driving vehicles. And there is a significant difference between connected vehicles and automated vehicles. Connected vehicles are truly a communications platform. It's the ability of vehicles to talk to each other on the roadway, to sense each other on the roadway through this communications platform, as well as to be able to talk to infrastructure on the roadside, and in essence be able to get information related to safety and operations. Automated vehicles, on the other hand, are about taking away some of the activities from the driver and transferring them over to essentially special use computer systems. These are vehicles that have the capability of sensing their environment and actually navigating and making decisions sometimes much faster than a live driver. When we look at connected vehicles, there's really three different components. The terminology we use is V2V, V2I, and V2X. V2V is a vehicle-to-vehicle communication, and this allows automobiles, when they're driving down the road, to actually sense what is happening maybe 3 or 4 or 5 vehicles in advance, so that instead of rear-ending somebody, when somebody 3 or 4 cars down the road steps on the brake, your car with an automatic braking system and a connected vehicle sensing system can actually begin applying that brake well in advance of when a human could do that. V2I is the car talking to the infrastructure. And this is one of the ways that we can dramatically improve not just the safety, but the throughput on the roadway. Because if your car not just senses where you are in the road because it can see the lines, but if it understands exactly where you are in the roadway and also where you are in relationship to the next car, it can cut down the distance between the cars. And when you do that, you put more cars on the real estate, and therefore you increase the amount of capacity of the roadway. And that's something we've talked about in a number of our past segments, right. This idea of how much throughput you get on a roadway. Today, I think we're in the 2,000 range for limited access lanes. 2,000 vehicles per hour that's the ballpark, 18 to 2,100, essentially how many cars you can get through a lane. When you add the connected vehicles, V2V and V2I, into that system, you can dramatically increase that. So instead of pouring more concrete to deal with the growth in trips, we use technology to improve the ability to handle the trips, the capacity of the road. And then V2X is about the communication of the vehicle to an individual receptor, and that's typically meant to be the phone systems. Could be something else in the future. I don't know if we're going to sew any chips into the back of behind our ears, but it's essentially a communication of the vehicle to some external source, and that's more of a safety function to alert the vehicle before the driver even can see it, that you have maybe somebody in a walkway, right? Mm-hmm. Or that an incident has occurred at an intersection before you visually can see it, and the car begins to reduce its speed. Maybe not brake, but bring its speed down until it verifies that incident. So connected vehicles are really going to provide a huge change in the way we do things. They also are going to provide, Tom, I think because it's a communications platform, an opportunity for the tolling industry to leverage that communications platform possibly for toll collection. I know this is some research that's going on right now in the private sector. The next piece of this, the automated vehicles, that's really a completely different ballgame. Google's self-driving car is a great example. This is about a car being able, again, to sense its environment, to have a number of different receptors built into the vehicle, and being able to, either through an electronic means or through video cameras, recognize activities that are going on around it and make adjustments before the driver can even respond. And we're seeing a lot of pilots going on. What's interesting about automated vehicles and connected vehicles is that Connected vehicles will work fine without automated vehicles. Automated vehicles can work without connected, but they work a whole lot better with a connected vehicle system. So add the communications platform of connected vehicles to the automated vehicles, and you increase the amount of use cases that automation will function within. Lot of research going on. Michigan has this automated bus that they've been experimenting with for a couple of years. They have a whole track up outside of Detroit where the University of Michigan is testing all forms of automated vehicles. We're starting to see some limited use of driverless buses, low-speed buses in urban environments, and these are essentially pilot projects that are starting to try these things out, but in low-risk environments. So SAE, to try and simplify this for people, has generated this chart that shows the various levels of automation. And they've broken automation down into 5 levels. And the first 2 we're pretty familiar with. They are essentially driver assistance, they're partial automation. These are things that we've been experiencing now for a couple of years. The types of cruise control that we have on automobiles, there's lane assist programs that are actually camera-based that can identify lane lines on the road. And if your car starts to veer out of the lane line, it'll send you an alarm. But all of them require some type, and usually some high-level type, of driver involvement. These are really not automations. They are really more assistance-type programs. The first level of automation that we're seeing is called conditional automation. And that's pretty much where the technology is today. And when I say the technology today, we certainly have gone beyond it in terms of our research, but we're seeing applications of this conditional automation. And again, the driver still has an important role. The driver has to be aware. We've actually seen incidences on the news where people have turned their cars over to automated systems, and unfortunately they have not maintained the vigilance, and it's ended up being some pretty devastating accidents. So that's the level of our current automation. The next 2 pieces are really the important pieces, and it's kind of where we're headed. High automation really can turn the vehicle completely over to a mini computer in the car. It's only under some very specific use cases. So this might be, for example, on a highway that has a connected vehicle system, that has a V2I already built in, and in that environment, the automation may be able to take over and provide a very safe trip, safe environment. But it's limited use cases. This is not for everyday driving on every road. The last one, full automation, that one says that your vehicle is capable of sensing everything in any environment. There might be a couple of use cases where it's not permitted, but virtually all of the general use cases of driving can be turned over to the vehicle, and it can drive completely without any kind of driver involvement or backup. What's interesting about all of this is as you move up the scale of automation, the thought process within our engineering and planning community is that this is likely to increase the amount of trips that we're looking at, because it's going to open up transportation to a wide range of people who normally would not be driving a car. And that kind of takes us to the next piece of this, and it's called Mobility as a Service and the New Collaborative Economy. MaaS, M-A-S-A-S, MaaS, Mobility as a Service, is a terminology that we use in transportation to talk about something that's truly already happening. it's really a shift away from personally owned vehicles. In the transportation sense, it's moving to modes of transportation and mobility that we consume as a service. So instead of owning the mode of transportation, whether it's owning a bike, owning a car, owning a motorcycle, it's actually sharing it or consuming it as a service and paying for that service as you use it. This is really enabled by a service that's provided either by the public or the private sector, or maybe in combination with both, that creates some type of uniform gateway, some type of platform that manages all of this and very often assembles multiple modes into a single trip that consumers can buy, again, using a single account or a single payment source. So MaaS is going to have a major impact. The work on this, the research on this that's being done is coming out of the IBTTA Platinum Sponsors Group. And I know one of your friends, Tom Delaney, has been heading that group, and he's been doing an awful lot of research in this area.
There's a lot of research going on, and we're kind of seeing an aggregation of different areas, and we're going to talk about 4 of those in the next few minutes as it relates to MaaS. And these are about mobility providers, about mobility aggregators, mobility integrators, and then the e-commerce industries that support those. So let's first talk about the providers. The providers are the ones that own the vehicles or own the method of moving you around or moving goods around. And they provide the consumers with the wheels that will help them move. And these providers, they're not necessarily going to be you and I anymore. They're going to be big companies. They might be some of the current companies that you might have heard of, Zipcar, or some of the rental car companies. Some of the Fords, GMs, Toyotas might be moving into these as using the car as a service to sell to others that would then pick you up and move you around. But these are known as the providers. They provide the active devices that will move you, the hardware in many cases.
So I think what's interesting about the MaaS providers is that some of them have actually been around for a long time. Rental cars, taxi services, there's nothing new about ride sharing. What we're seeing is now different forms of it and some disruptive approaches. One of those disruptions is probably going to change car ownership. And because of that, the car manufacturers themselves have decided to get into this. You know, they're pretty strategic in their thinking. When you sell millions of cars a year and something comes along that's going to disrupt your business, you better pay attention to it. And I think Ford and GM and Toyota and the European manufacturers have all seen the writing on the wall, and they all are developing approaches to getting involved in this business. So it wouldn't be surprising to see Ford and GM and BMW involved in the car rental and the car sharing business in the not too distant future.
So the next group we have are the mobility aggregators. And the aggregator's role is to provide the end user, you and I, with the connection to the merchant and with solutions that will help make this multimodal network work. And so we'll see public or private brokers and operators come together to offer other mobility services. And these can be ways to connect people who need rides to where the vehicle providers are, and to be able to link the user to the devices. And we're also seeing some of these now in some technology platforms for fleets, where we have account providers that provide toll payments, whether it's bank pass or pre-pass, or others that help facilitate the transportation network. You know, we're going to see more of these commercial enterprises come up and help people make those connections. And we'd even put like the Uber and the Lyft type of aggregators into this category of being a MaaS provider in that space.
Essentially, these are brokers. They don't really own the transportation. They link you as a consumer to someone else who's providing it. That could be a single trip, or it could be multiple trips. Typically, these are private providers. These are private companies, private entrepreneurs who have gone out and said, you know what, I think I can make money doing this. Even though I don't provide the transportation, I'm going to facilitate the connection between the customer and the providers who actually own these systems. Waze kind of falls into that category. A lot of us use it in our car. We don't really understand how they make money, but I think just like Google and some of the other internet companies, they generally make their money by either through advertisements or by collecting the data, the transportation data, our preferences about how we drive, and not just individual preferences, how the groups, that group data is really valuable to companies like insurance companies, extremely valuable to the car companies, for them to be able to see what people are doing, how these disruptive approaches have changed the way they take on transportation
And
use
Waze,
transportation.
Waze is a good example. They just recently are making the toll rates visible. As you use Waze to drive down the road on a toll road, the toll amount will pop up on your screen. So imagine in a few years, Waze has figured out a method to make that transaction happen too.
Oh, yeah. I mean, just think about it. If they can tell you what the toll rate is, and through some kind of geofencing, they can identify that you just passed a tolling point. And if there's some kind of connection between their system and the customer and the toll agency, you basically have a payment system. It's not such a big leap to get there.
So the third category is the mobility integrators. And these are the ones that provide the software, the technology. They seek out ways to educate people on how to use them. And they're the ones that provide the fabric that lets the providers and the aggregators come together. And so integrators it's a commercial opportunity for many. I mean, you can see in multi-jurisdictional areas where different integrators would come in and stitch all those different pieces together and make a technology product you could use. So that's an area where I think there'll be a lot of future development.
And when I look at some of this nomenclature, it seems to me that some of these people might really be falling in one category or more than one category. Yes. Because here you've got things like the Paris Pass. If you go to Paris, you can ride the light rail system, the metro, you can ride on a bus, or you can go to certain attractions like the Louvre, all using the same pass. You can travel all over Europe using Eurail, and that's really a loose confederation of all types of rail providers, but you can book sometimes, not all the time, but you can book the rail, but the Eurail pass is accepted. And then you have things like the charge point that fits into this. These are really disruptive technologies that are going to change the way we do things in the future. And this is kind of a good lead-in to the next piece, which is that e-commerce, that new collaborative economy that has really changed a great deal of how we as individuals shop, how we travel, and really how we buy things. We think of Amazon as being the initial disruptor in this, but over the last few years, the Best Buys and the Targets of the world have bought into this system. They now have the same type of e-commerce approach that the Amazons have. And Amazon has got some spin-offs, Wayfair and other systems out there. And some of the research that's being done in this area is now pointing how our mores and our approaches to living are changing and how that affects transportation. When you look at it, what's happening is there's an adoption rate that looks like extremely upward curve. 90+% of Americans today shop online at least one time throughout the year. That's an amazing number. I didn't know that 95% of Americans even had access to computers to be able to shop online. But that's an amazing number. That's overwhelming. 80% of Americans shop online monthly. That's a number that astounded me when I saw this research. 30% shop online weekly, and that you've got 5% of our population that probably lives on their computer if they're shopping on it daily. But the younger our population gets, the more they're embracing this technology. And while that term millennials is, I've never really understood exactly where the cutoff line is for who fits into that, but it shows extremely high adoption rates for younger people to shop online instead of going to the store. The retail projections are that by 2022, we're going to be looking at $900 billion, almost $1 trillion of shopping on an annual basis by 2022. That number is astounding. But what does it mean for transportation? What does all of this mean? What are the impacts from these changes and disruptions on congestion? And these were the 6 areas that we were talking about. Let's take a look at what the impacts are and what it means to the future of transportation and for tolling.
So car sharing, we talked about the aggregators and the providers and the ability to use a car as a service. So we believe there'll be a 3-time increase in car sharing in the next 5 years or so, and that will continue to increase over time. And what that might mean is there'll be a reduction in the fleet. There may be less vehicles, but they're moving all the time. So the cars are going to be moving, they'll be on the road more often, and that will associate with more trips. So a car is moving to pick up the next person on their fare. They just continue to move around a network, pick people up and move them around. We also see things like bike and scooter sharing, that's a reduction in primarily maybe transit movement, because transit typically moves people within a city. There's more bike and scooter use as mobility as a service, then there may be a corresponding decrease in some of the transit methods, or transit may need to reshape their current approach on how they deliver their service.
So this is all based on research. We're not making this up, right? And we've tried to attribute the research on our graphics. In fact, this approach is now also being embraced. This car sharing and bike sharing and trip provision is being embraced by the car manufacturers. I had mentioned that earlier. BMW has already done some projections about how that's going to affect their business. And what they see is, even though it may change car ownership, they really believe this is going to generate far more trips into the future, and therefore it's going to impact congestion. And higher congestion is normally good for the toll business. When you look at trip sharing itself, we've really seen some problems on the carpooling side that are also driving us into this philosophy. I know that Tom, HOVs, high occupancy vehicle lanes, was a strategy developed a long time ago by the Federal Highway Administration to try and impact congestion. And in some areas it has been effective, and in other areas it has not.
That's true.
Where it hasn't been effective is where the HOV lanes have just filled up and been just as congested as the outside lanes. This picture of Atlanta is a perfect example of that. But in some places, the HOV lanes were underutilized, so we paid for an extra lane, and we're really not getting much use out of it. Overall, if you look over the past 30 years, there's been no significant reduction in urban congestion that you can track back to HOVs. Now, you might find 1 or 2 places where it specifically has worked, but overall there has been no significant reduction in congestion from these diamond lanes. In terms of ride hailing, this is one of the interesting things that we've been looking at in transportation, because this is essentially a fairly new activity. Uber and Lyft have started just a few years ago, and now they are multi-billion-dollar companies, even though they actually don't provide the transportation themselves. But ride hailing, this really isn't ride sharing. This is just a different way for you to find a ride and get a ride when you need it, to use transportation when you need it, not pay the capital cost of the transportation, or even the direct operating and maintenance cost of the transportation. You're just consuming it as a service. These are pretty interesting numbers, that the market is really less than 1% of total trips or total VMT, but it is growing at an incredible rate. The fact that 25% of adults in the US are now regularly using this kind of a service says that we've had a tremendous shift in the mores and the acceptance of this new approach. The ridership now in 2017 was 37% ride hailing, and that's going to grow in 1 year, or it did grow in 1 year to over 60%. That's an incredible jump. So U.S. ridership and ride-hailing trips, they really substitute a large percentage, and you had mentioned this about scooters and bikes. These also represent a large percentage of trips that would have been handled by public transit. So a lot of people think that, wow, this is going to replace our ownership of cars, and what it has done is impacted a much wider piece of the transportation landscape. It's impacted the people who operate public transit, and it's actually reduced trips on public transit. But some of the other results are pretty amazing as well.
Right. So under some of the results of this, as you mentioned, Marty, the transit trips are down, and we're going to continue to see those go down, I think, in the near future. In fact, if you drive around New York, you're going to see Uber and Lyft vehicles everywhere. They're the ones clogging up the roads now in New York, but they are moving people that the subway or the transit system might have moved before. We're also seeing that upwards of 22% of the ride-hailing trips are now trips that would perhaps not have occurred in the past. People wouldn't have necessarily thought to make that trip unless they had the convenience of the ride-hailing service. And then the overall effect, as I mentioned, it's negative on the transportation network because there's more vehicle miles traveled, VMTs, with empty cars in them going to pick up the next ride. And so that actually adds to the congestion in our urban areas. And we expect that overall in the next few years that this VMT range is going to grow from 50 to 200%, double, perhaps double in the number of trips being requested over the next few years. And that's going to just put more of a strain on our congested transportation networks.
It's actually growing so fast and changing so fast with numbers that we've never seen before that it's giving forecasters a real challenge. That's why you're seeing such a wide range here in terms of the projected future, because I'm not sure that a lot of people in our business really know what's going to happen. So they've couched it by increasing the range.
It's a disruptive technology to us.
Absolutely. Yes. And then when you're looking at e-commerce, this is the piece that a lot of people do not think about. It's the doorstep delivery. It's the part of the ordering of things from Amazon or anybody else's e-commerce platform that has dramatically impacted transportation. And it's impacted in a way that no one ever thought about. It's this rule of unintended consequences. So we have changed our buying patterns. You saw that in the earlier slide. What does that mean in terms of trips? Well, there are a number of things that happen because of that. First of all, people's buying habits have changed. Instead of shopping on the weekend when you're off work and going out to retail stores, people are shopping at any time they want, shopping in their pajamas, and they're ordering, but the deliveries are not made on the weekends. most deliveries are made during the week. So instead of shopping trips on the weekend, the delivery trips are now during the week, and they're generally during the normal work day. So what we're seeing is a huge increase in urban trips to make these doorstep deliveries. It's something that we don't think about, but it has impacted urban congestion in a significant way. And these are a lot of new trips that not only are replacing trips in cars, but they're replacing trips that some people would make by foot. They would walk down to the local store if they live close enough to buy something. So it's not just adding trips at a different time, it's actually adding trips that never occurred before. This is a phenomenon that really nobody ever thought about. And it also adds multiple trips for what often used to be one single trip. In the transportation planning business, we call it trip chaining, where on a Saturday you might get in your car, drive to 2 or 3 stores, stop at the cleaners, stop and have lunch, and then come home. That now, when you order a lot of these things online, becomes 4 or 5 trips. So instead of bundling them into one trip, they become debundled into multiple trips, and they're adding to more congestion on the roadway.
Right, and the result is more congestion. The result is the heavy traffic demand that we see during the weekdays is only increased because we don't have those shopping trips on the weekends anymore. So we're seeing that traffic demand really intensify during the week as all those e-commerce deliveries are moving around. And somewhat like brick and mortar was affected by e-commerce, also the transportation network is affected by the e-commerce.
Yeah, it's really impacting weekday congestion. But what's going to happen when connected and automated vehicles become a significant part of the travel stream?
Well, a lot of different things may happen as a result of that. And some of the stuff we're looking at, we know it's going to take a while for automated vehicles really to become the mainstay of cars. It takes almost 20 years for a vehicle fleet to switch out. It means people keep their cars for quite a while. So the effect of automated vehicles is going to be spread over time. But we expect that, we're seeing numbers that maybe 10 to 50% of the vehicles on the market in the next 20 years may be automated vehicles. So the adoption rate's it's going to take a while, but when it gets there, it's going to radically change what we're used to. It's going to increase our road capacity because, as you mentioned earlier, those vehicles can follow each other much closely down the highway at highway speeds. So we can get more vehicles on the road. But the increase in demand is also going to be higher because these cars, after they drop you off at your workplace, are going to go pick up your child and take your child to school, and they're going to continuously be on the road, moving your family around, as an example, or going to pick up other riders. So that's going to increase the miles traveled, but also could change our perception of what it means to be driving. We could get our car and sit in our car and take a leisurely trip on our device, playing Wi-Fi or playing games or doing our business as we make our trip into our job if we have to go into our physical job that week. And so that's going to perhaps change where people are going to live, because your time in your vehicle can be spent doing a lot of other things other than doing what you do now, which is make sure you're safe while you're driving.
So if we're increasing our road capacity by 25%, and engineers think that when we get to real high adoption rates of connected vehicles and automated vehicles, we could actually add 25% capacity to the existing highway system. That's a huge increase. But if you're increasing demand by 60 to 70%, that means you're still losing. You're still looking at higher congestion. Certainly in the short term, we're looking at more congestion. What does it really mean in the long term? From what I'm seeing from a lot of the experts, higher VMT, higher vehicle miles traveled. It's not necessarily the vehicle miles from one car, but the vehicle miles traveled. And full CV and automation means a lot of those trips are empty. Mm-hmm. So those empty trips, even we're seeing that today. Uber and Lyft When an Uber or a Lyft driver has two trips, usually between that trip, there's an empty trip as they move from that location to find the next location. And if you ever use one of their applications and look at an urban area and say, okay, I want to get a trip, and you look down there and you see there's 15 people trolling around down here looking for fares, that's what's causing the congestion in New York. It's my understanding that congestion has significantly increased, and it's really the mobility as a service, the MaaS, Uber, and Lyft drivers who are all looking for fares in Manhattan.
I read a report on that today. Up to 30% of the trips in New York are empty right now looking for fares.
So when we look at how this is going to impact tolling, what does all of this really mean? First of all, we think mobility demand is obviously going to go up. The new technologies and the business approaches, they're all fulfilling demands that could not be fulfilled from somewhere else. We're really not creating trips, we are fulfilling demand. So we don't make the trips, people want these trips made, or they've ordered goods. And this goods part of this is something that a lot of folks do not think about in our business. So we're creating demand, and these different technologies and business approaches are fulfilling those demands. What we've learned over the past, I think, 5 or 6 years, certainly over the past decade, is that we need to be careful before we rush to judgment and accept quick predictions of what's going to happen, that X is going to create Y, because some of the things that we thought were going to happen because of Uber and Lyft and some of the car sharing that's going on, some of that has been just the opposite of what was originally predicted. There are major threats out there from new technologies and vehicle ownership, but I don't see these threats being to tolling. In fact, I see them offering opportunities to tolling. I think there are going to be threats to some other public activities, specifically parking. I think we're seeing that already, that ride sharing and ride hailing and trip sharing is going to affect the demand for parking in urban areas. I think traffic congestion is going to continue to grow. We're already seeing that. VMT is going to continue to grow, both in the short and long term, because of limitations on transportation resources. And I think this is a really important part of this, and it's not something we've talked about. It takes such a long time to put a new highway on the ground. It takes a long time even to widen a highway. And the limited resources we have to do that means that we're always behind. We're always chasing congestion, always chasing demand. And it looks to me like this new technology might have more impact on that than our ability to build our way out of this congestion. And then I think this last one, that changes will not eliminate the need for premium facilities. In the beginning, when we first started to see these disruptions, a lot of people in the toll business got a little nervous. They thought these payment systems, these different mobility as a service platforms were going to have a real negative impact on tolling, maybe take our industry completely out, maybe have an impact on us like it has impacted the taxi business. But I don't think that's really what's happening. I think we have an opportunity to do something here that's just the opposite of that.
I think the toll agencies are going to be the providers, and the asset they're providing is the physical roadway space for the vehicles to move across. And I think the way we make payments now and the way we receive payments from individual customers may be changing quite a bit over time as we see these aggregators and these other entities come in to be able to make the payment on the end user's behalf.
I think most of the conversation we've had in the toll business has been that it's really important for public agencies, public toll agencies, and the private side of the tolling business to be involved in this conversation. that when it comes to mobility as a service and how these platforms work, and the fact that the platform is now often dictating what service you will use, what roadway you will take, we need to be involved in that. If we sit on the sidelines, that's where the negative impact might come.
Yep. We need to be a player in those discussions because we provide, again, part of the solution to the mobility needs.
So this has been kind of look at the future, not just the future of tolling, but the future of transportation, and how some of the new disruptive technologies and activities are impacting us today and how they might be impacting us in the future. And we've taken a look at what we think some of the effects are going to be on tolling. I'm Marty.
And I'm Tom.
And I hope you've enjoyed this segment of Toll 101 and that you'll take a look at the other segments in the series. This program is made possible through funding provided by Aegis Projects, Inc., and with the additional cooperation of Atkins, Valencia College in Orlando, Florida, and Patterson-Bach Communications.